This is a basic arithmetic video on the conversion of fractions, decimals and percentages. To write 0.36 as a fraction in its simplest form, there's a couple of ways of thinking about it. We could put a 1 under the decimal point and a 0 for every other digit, and you can see in there that that will turn that fraction into 36 over 100. Another way of thinking about the fact that this would have 100 on the bottom is to concentrate on that final digit there and ask yourself, what place value does that 6 have? That 6 is in the hundredths column, and so that would lead us to think that the bottom of that fraction that it'll turn into will be 100. Now it does this question ask us to put it into simplest form, so that asks us to think about a number that can divide into 36 and into 100, and I'm here to tell you that 4 can go into each. Divide the top and bottom by 4 and we'll get 9 over 25 as our simplest fraction there. To express 3/8 as a decimal, we could type it into our calculator and press equals, and perhaps then press the S to D button. That would get us a decimal here, but if without a calculator we'd acknowledge that a fraction, or remember that a fraction has the bottom number dividing into the top. So if we do that in a decimal type way, we can get a decimal answer here. We're allowed to write any number as having a 0.000 after it, as many zeros as we like. If we divide the bottom into the top, we'll get a decimal answer there. 8 goes into 3 no times. That decimal point would have to come up the top directly above where it is in the question, and that 3 would carry over. So 8 into 30 goes 3 times. 3 8s are 24. That would carry over a 6, a remainder of 6. 8 into 60 goes 7 times. 7 8s are 56, and we'd have 4 carrying over there. 8 into 40 goes 5 times. So if we didn't have a calculator, we could do that division of the bottom into the top and get a decimal of 0.375 as our answer. And that's the conversion of 3/8 into a decimal form. 19% as a decimal. Well, percentages and decimals work very well if the percentage is a two-digit number like that. So 19% is 0.19. We could think of this as being 19 over 100, because every percent is over 100, and then we could think about how that turns into a decimal there. But that's our final answer, 0.19 there. If we wanted to convert 13 over 20 into a percent, to go from a fraction to a percent, we will write it down and multiply it by 100. That sort of makes it of or out of 100, I guess. And we could then think of what could go into both of these. We could do the multiplication across the top and then across the bottom. But before we do that, we're allowed to find things that go into the bottom and the top of either fraction here. So 20 can divide into that once and into that 5 times. Then we could multiply across the top and across the bottom. Gives us 65 over 1. Leads us to convert 13 over 20 into 65%. So that would be one way of doing it. Okay, to write 2.38 as a percentage, let's remember that one whole number is actually 100%. And 2 as a whole number would be 200%. So something that's bigger than 2 will be 200 and something percent. So we put together that idea along with the idea that 0.38 would turn into 38%, because that's the two digits straight up the decimal point end up being like the percentage digits. So we're really putting those two ideas together, and we'll get a final answer of 2.38 as a percent of 238%. Because 2 point something is bigger than 1, it's bigger than 2, so it's 238% there for our final answer. Writing 3 over 7 as a recurring decimal, we'll do it a bit like we did with the other fraction, where we divide the bottom into the top there. We can start off with 3.000, as many as we like. We might need a few zeros on this one if it's going to keep going on and on and on. But if we divide 7 into that, the bottom of any fraction divides into the top. 7 goes into 3 no times. We'll put the decimal point above there and we'll carry over the 3. 7 into 30 goes 4 times, so 4 sevens are 28 and carries over the 2. 7 into 20 goes twice, 7 twos are 14 and leaves you to have a 6 carried over. 7 into 60 goes 8 times, 7 eights are 56 and carry the 4 over. 7 into 40 goes 5 times, 7 fives are 35. 7 into 50 goes 7 times. This is a long-winded example. I don't know who chose this. I think it was me. But anyway, 7 into 50 goes 7 times. 7 sevens are 49, carries a 1 over. 7 into 10 goes once with 3 left over. And we notice that carryover of a 3 is the same as what we started with. So what will happen here is from here on, as we continue across here, we'll get repetitions of the same number being carried over as our remainder. So when you see one of these numbers repeating, then you can kind of stop there and be confident that that will keep cycling through what's happened already. So this section would just keep repeating here and onwards further as we keep going there. So what we can do now is be confident that this section we've done so far is going to repeat, and we indicate that by putting a decimal point there and a decimal point there. So our final answer there, this as a recurring decimal, is 0.4285571 with a decimal point at each end there. That's how we write that as a recurring decimal. Pretty ugly example, but that's how we do that. We divide the bottom into the top, and where we see that it repeats, we just put those repeating signs up there. Okay, expressing 0.7 repeater as a simple fraction. Now let's just write it out as it would be if we wrote it out like that with dot dot dots continuing. And we've got to go through a special process here. What we're going to do is let x equal that, and then we're going to think, okay, what would happen if we multiplied both sides of this so far with 10? We'll have 10x equaling, now when we multiply a decimal by 10, it moves the decimal point 1 across to the right here, so we'll end up with the decimal point being in there. So we'll get 7.777 dot 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 there. And now what I'm going to do is I'm going to rewrite this first line underneath this this line I've created there with my tens. So if I just drag that line down to here, I will get an x equaling 0.777 there. That's a 7. Okay, I'm doing that for a specific purpose because I'm going to take this section here and I'm going to subtract 1 from the other. Now invisibly there can be a 1 in front of that x there, so if I do a big subtraction between here, what we'll get happening is we'll get this section here, this repeating decimal bit, cancelling each other out. So anyway, let's do 10x minus 1x. That's going to leave us with 9x on that left hand side. And on this side, can you see that this chunk here and this chunk here are identical to each other, and when you subtract something that's identical, it cancels it out. So it kind of cancels that bit and that bit out, and 7 take away 0 is just 7. So that's pretty fancy. Okay, and then to get x on its own, there's an invisible multiply between these. We divide by 9 and divide by 9. And when you divide by something, it can be stated under it as the bottom of a fraction. So it'll end up being x equals 7 over 9 as our simple fraction. Quite a process, but I'm sure you've seen that in class, and this is just a revision, I'm hoping. So that's how you do it for expressing a repeated decimal as a simple fraction. So that's when we've got one digit there, and we'll move on to another example here where we've got a couple of other digits and it's a little trickier, but yeah, so it's an interesting method. So here we've got 0.526 repeated, and it's just the 2 and the 6 that's repeating. So that's going to be pretty interesting. In this one, we're going to start off by letting x equaling 0.526. Now with these repeating signs here and here, it's just the 2 and the 6 that repeat. And then it continues. So that 5 bit doesn't repeat. So we want, when we play around with this, we want the section to the right of the decimal point to be the repeating bit. So what I'm going to do here is get a bit fancy. I want to start off by multiplying both sides by 1,000 this time. Now I'm doing this for a purpose. I'll explain it a bit as we go. If I multiply this by 1,000, that decimal point will move across here. Can you see that that's going to be 526.2626 and onwards? And then if I multiplied just by 10, I'll get the repeating section after the decimal point again. So I'm choosing 1,000 to multiply it by, and also 10 to multiply it by. If I'm multiplying it by just 10, it's going to just move it to here. So can you see that that will create a 5.2626 onwards. And I'm going to then use this section here to subtract and cancel out my decimal bit. So if I put a big subtraction sign there, on the left hand side I'll do 1000x minus the 10x, which is going to be 990x on the left hand side. Here the bit after the decimal point is identical with the bit underneath, so when that subtracts that'll disappear totally. And I'll just do the subtraction on the 526, take away the 5, so I'll get 521 there on the right hand side. But what it's done it's cancelled out nicely the bit that's the repeating decimal and just left us with a little equation to solve. If I divided both sides by 990, that's a 0, 990, I would cancel out there, leaving me just with x. And here we can write that as a fraction with the 990 underneath. You know, dividing things end up having being the bottom of fractions. So that is the fancy simple fraction version. It's not all that simple, but simple fraction version of 0.526262626. So that's quite a bit of a process there. The reason I had to get fancy and multiply by 1010 was that I wanted to create a scenario here whereby the right hand side after the decimal point on both of my versions here were identical, and they were just exclusively made up of the repeating section. So that's how we do that one. Alright, so we saw a good set of examples there converting fractions, percentages and decimals. Thanks for watching. peterblakemaths.com